I'm Dr. T.Srinivasarao, working as a associate professor in computer science department, Geetam University. Today I'm going to present a paper titled Semantic Condensation through Self-Attention Mechanism in Transformer Architecture for Automatic Text Summarization. I'm going to, this paper is to be presented communicated to one of the conferences held in Jordan the coming December 18 to 2025, International Conference of Digital Technology Driven Engineering 2020-25. The following co-authors are my mentor, Dr. Sasanko Sekhar, Gantayat, and Kodanda, Brahmanandam, and Sunil, Chandolu, and Teja, Karri. See, today how everybody knows because of ubiquitous network, how the data is to be populated, how data is to be generated and stores, how volumes of data and how you can able to handle, how able to process the data. It is a very one of the challenging and promising task to every researchers and academicians. Moreover, not only storing, processing, and analysis, whenever the transformers are came into a existing into a booming technologies, okay, we can able to summarize the data also. Okay, that's why today how people create huge amounts of digital text in every field, so just like news, social media, healthcare, business laws, and moreover, we need some automatic systems that can quickly and accurately summarize long information. The invention of the transformers models completely changed how computers understood and process languages, and is now forms of the basis of most powerful text summarization tools. In this survey, how summarization technology has developed over time from early methods that rely on count of using simple graphs to modern deep learning approaches based on the transformers. In this survey, we introduced a clear classification of different transformer models and explain how they are used for both extractive summarization and uh, abstractive summarization. Extractive summarization is nothing but picking important sentences, and abstractive summarization is nothing but rewriting the text in a new way. We also explore the latest trends, including summarizing multimodal context, text plus image plus audio, handling very long documents like books or legal files, and hybrid systems that combine uh, and generative methods. We look the major data sets and evaluation methods used to train and test these systems and how these choices affect model performances. Finally, we highlight ongoing challenges such as ensuring summaries are factually correct, reducing the high computation cost of large models, and making AI systems easy to understand. We also discussed promising research directions that can help to improve the reliability, speed, and real-world useful of future summarization technologies. This is an introduction how automatic text summarization provides concise and meaningful representations of large documentations or collections. Mainly how this survey helps to prevent silent information while reducing reading and processing time, and how key applications and how real-time news aggregations and scientific literature review and synthesis. Business intelligence, how business intelligence helpful for enterprises document analysis. Accessibility tools, we also discussed about the accessibility tools and all. Generally, before going to start this survey, how we are processed the paper. how earlier automated text summarization techniques are used in the mid 20th century, how rule-based and statistical heuristic approaches are used, how relied on surface features such as word frequency and sentences positioning, how introduction of graph-based models also, how they represent documents as a networks of sentences, improve redundancy handling and context ranking. Example, text rank and lexical analysis. Deep learning also we have discussed how neural networks learn better training text presentations. This is simple diagram, a timeline simple illustrating in 2010 rule-based and statistical approach followed, 2010 machine learning, 2010 deep learning, 2022 transformers are how they are now currently using. The transformers revolutions, how these this paper contributions and survey structure of this survey expanded with some real-time examples. Okay, this survey mainly provides a unified, comprehensive understanding of how transformers-based models have emerged. The the base main key contributions are elaborated below with clarity, depth, and real-world examples. For example, a structured taxonomy of transformer-based models, and we develop a clear taxonomy, just like a classification systems that organizes transformers models accordingly. And also we have discussed about the architecture family, how encoders are used, just like BERT, and decoders like GPT and bar cutters and BART and T5, how they were used. Okay, these are mainly developing summarizations. Mainly they are type of new summarization, scientific summarizations are there, meeting transcriptions we are considered, and dialogue summarizations, product review summarizations. These are all mainly how they are taken as some benchmark for helpful. This survey provides a unified and a comprehensive understanding of how transformers-based models have evolved and are being applied to summarization. The main key contributions are elaborated below with the clarity, depth, and something. And the remainder of this paper mainly organized as follows. Okay, section 2 mainly we defines foundation concepts and reviews pre-transformer approaches. Section 3 presents the transformers. Section 4 presents a taxonomy of transformers-based summarization models. And Section 4 surveys advanced frontiers. Section 6 analyzes the data sets and training practices and evaluation matrices. And Section 8, we discuss open challenges and future directions sections. And 8th, we are concluded with that. See, these are the foundational concepts of in automatic text summarizations. Mainly, we had seen the difference between the extractive summarizations. There are main two types of text summarizations. One is extractive and abstractive. In the extractive summarization, it mainly picks the important sentences directly from the text. In the abstractive, it generates a new sentences that captures them. It will generate and also bring the meaning of the original text. It also bring the paragraphing styles, pricing styles. Okay, these are the key traits of extractive and this abstractive. See, extractive summarization, it creates a summary by selecting important sentences, phrases, or words from the original content. How they are followed, these are the following steps are followed. Those are called as a pre-processing, cleaning the text. It's nothing but tokenizing and normalizing. And processing is nothing but scoring. We have to calculate some scoring sentences using statistical features, graph-based methods, and machine learned important predictors. The post-processing, removing in that what we have done means removing the repeated informations and arranging sentences for better flow. Abstract to summarizations generates a new sentence that paragraphs that paraphrase the important ideas, working at the meaningful level, not just sentence selection. It advantages more natural and more concise summaries. History, history before transformers, statistical and feature-based methods used simple features like a TF, IDF, term frequency, and inverse data frequencies. Okay, these are all mainly used. Okay, before 204, most summarization systems use shallow statistical heuristics. Okay, TF-IDF mainly scoring sentences with the rare but important word scores high in that. Keywords, Q phrases mainly sentences starting with in summary. This paper presents like that the Q phrases will be following. And sentence positioning, these are mainly focused on positional features. First sentence in a new article is often the most important they will be considered. Why these approaches were limited means these methods did not understand the meaning of the sentences. They only counted words. So they often fail when paraphrasing or deep semantics were required. Graph-based methods. The next model is called graph-based summarizations was introduced to address redundancy and also improve document level understanding. These are mainly used. Okay, limitations means still no true semantic understanding, could not generate abstract to summarizations. Early deep learning. Okay, in that sequence to sequence model, when early deep learning, sequence to sequential models is one of the revolutionary models. For the first time, models could generate new sentences. Summaries becomes more like humans, and some level of paraphrasing becomes possible. Okay, this was the first step towards the true abstractive summarization. Okay, these models had limitations. Some of the limitations are also there. Those are called processing tokens sequentially, very slow, and poor long-range memory, and difficult to parallelize. These are all some limitations will be there. And encoder decoder framework. This is one of the simple encoder decoder. The encoder decoder reads the entire input document and builds conceptualized representations for every token. Uh, Example, it reads the whole sentence and converts each token into a vector uh, enriched with this context. And decoder is also generates a summary of one. That's it's just like a writing phases. Okay, the decoder uses two important methodologies or techniques. Those are called as a self-attention and cross-attention. Self-attention attends to already generated summary words. Cross-attentions mainly attends to encoder outputs. Okay, these two are main factors is used. Okay, this structure fits abstractive summarizations uh, which needs both understanding and generators. Self-attention and multi-head attention. Self-attention core idea is to allow each token to look at every other token in the inputs and decides. This is one of the self-attention. And scale dot protection, main attention is scale dot protection. It computes the similarities between Q and K, applies and also applies softmax to generate attention weights, and also multiplies by V to get output. And third one is called multi-head attention. It runs multiple, instead of one attention mechanism, the model runs several parallel attention heads. Okay. Example, it follows the grammar, meaning, and a reference between sentences also. For example, head 1 follows syntax, head 2 follows semantic similarities, and head 3 follows long range dependencies, and head 4 named entity relationships. So these are all mainly follows. Positional encoding is also there. Okay, self-attention does not know the order of words by itself. Okay, positional encoding adds information about word position. Like many models are also there, encoder, bet and variants, word sum, uh, fine-tuning strategies, decoder only permutations, and advanced frontier in summarization, multimodal summarizations. Okay, this is one of the promising area. Nowadays, it is a boon technologies. Audio plus text summarizations. Audio is the first converted to text using ASR systems. Traditional text summarizations is applied to the transcripts. Optionally um, selected sentences can be mapped back to audio to create audio highlights. Here, audio plus text summarizations. Most summarization research goes beyond plain text and integrates nowadays and integrates audios, images, videos, and text summarizations. Okay, this is essential for summarizing meetings, podcasts, and new articles also, social media, content, and surveillance data, and multimedia archives. Audio plus text summarization and image plus text summarization is also there. Long, long out document summarization. Okay, standard transformer struggles with the long inputs because self-attention costs more complexity, time complexity that is 0 n square in memory and time also. Okay, researchers has mainly introduced specialized architectures here to handle books and legal documents and research papers and multi-chapter contents. Okay, these are all advanced frontiers in summarizations. Hybrid framework, extractive filters, and ranking-based extractions. Okay, these are all mainly benefits. And benchmark datasets, new datasets, CNN by summarizations, mainly research depends heavily on the types and quality of datasets used. Different datasets encourages different model behaviors. We can able to extract to and abstract to long form and multimodal, etc. Okay, these are all benchmark datasets mainly helpful. Pre-training and fine-tuning strategies. Pre-training and fine-tuning. Uh, this is mainly helpful for modern summarization, follows transfer learning. Pre-train onboard data, that is learning languages, and fine-tune on specific summarization data, learn summarization patterns. This is mainly helpful. And evaluation metrics. Most common metrics is used just like we have to evaluate the summarizing remains one of the hardest problem. Okay, mainly ROG metrics, rough 1 and rough 2. So it works by matching n grams between generated and reference summaries and also checking longest common subsequences also. The main advantage is fast and easy to compute, widely accepted. The major weaknesses or limitations are rewards word overlap, not exact meaning, penalizes rewrites and paraphrasing, does not detect hallucinations, and cannot measure the factual correctness. These are the key hurdles and open challenges for future research directions are factual consistency hallucinations, high computational cost, lack of interpretability, data requirement and domain shift, and human evaluation remains essential. Okay, despite AI metrics like fluency, coherence, and all, um, data requirement and domain shifts. Model depends on large annotated data sets. How these rough metrics is used, how weak evaluation matrix it has to be follows. Ethical considerations and societal impact, algorithm bias, misinformation, environmental cost, authenticity, and overall reliance. The path forward: few shot and zero shot learning, knowledge integration, efficient model designs, human in the loop approaches, better evaluation methods we discussed. The survey reviewed the evolution of automatic text summarization from early statistical methods to modern transformer-based models. We presented a taxonomy of summarization architectures, including encoder, and the mainly the transformer-based summarizations has transformed how we process information across industries, from news, law, and medicine, and also to multimedia platforms and enterprises communication tools. To data grows in volumes. Nowadays, we had seen and observed uh, volumes of data has grown in exponentially in the form of volumes, variety, and importance. Future summarization systems may tackle factual grounding, computational efficiency, domain adaptability, interpretability, and multimodal integrations. We also explored advanced area of such multimodal summarizations, long document summarizations, and hybrid frameworks. Coming into the last discussion of this conclusion, real world adoption will depend not only on better model architectures, but also on scalable, trustworthy, efficient generative frameworks that align with human expectations and the demands of practical deployment. Thank you.